So thank you so much for joining us, Sharai. And so Sharai is the lead adaptation specialist at First Street Foundation, where she applies her background in environmental policy and GIS to analyze data on flooding, vulnerability, and adaptation. And before that, she was a GIS specialist and project coordinator at COE, North America, and for the Regional Plan Association of Greater New York, and for FEMA. And we're super excited to be speaking with you today to hear more about the flood model, the adaptation database, and how your team's thinking about modeling all of this complex stuff can be used to inform climate migration models.
Thank you, Rachel. Thanks, ASAP. Thanks, Brianna, for having me and always inviting me to speak to these amazing groups that you coordinate and put together. They're super, super topical, and I feel very, very fortunate to be able to tap into them like this. So thank you all for having me today. Can you see my screen? My presentation? Great. Okay. So I know we only have about 25 minutes left, which is about as long as my presentation is. So I'm just going to try to breeze through it a little bit faster than that. So what I like to do is I like to give a little bit of background to First Street and why we exist, because I think that matters, so you understand the context of why we do certain things and why we don't do certain things and where we are today. And then I'm also going to show you our main communication tool, which is Flood Factor. And the reason I'll show you this is because I think it's a really good entry into our much more complete and complex data set, which would be available to you all. There are two ways in which our complete statistical data set is available to you all. If you're associated with a university, it's available through our Flood Lab. If you're associated with a government agency, it's available through my work stream, which is connecting public sector agencies, government agencies with our data sets. So with that, let me begin. Okay, so who are we? Well, we are the First Street Foundation. We're a nonprofit formed to communicate risk from climate change to the individual American. And we decided to start with flood risk because it is one of the most tangible and expensive climate-related risks that we face today. And we decided that we wanted to provide property-level comprehensive flood risk estimates. And we recognize that there's this urgent need for consistent property-level data that is publicly available for the entire US. Right now, we have democratized this peer-reviewed flood risk data through floodfactor.com, and we currently have 142 million properties in our database available for the contiguous US. We're working on Puerto Rico, Alaska, and Hawaii, and those should come out by the end of this year. So why do we exist? Well, FEMA flood maps are out of date. As you all know, FEMA is required to update their maps every 5 years. We found through our analysis that 75% of the maps are out of date. 11% of them date back all the way to the 70s and 80s. And actually, over 40% of the country has never actually been mapped, which I think is really astounding when you consider that the maps are the gold standard for understanding our flood risk. If you look at this map on the right of the US and you allow your eye to look at areas in white, you can see that those are the areas that are completely unmapped. So furthermore, FEMA flood maps are shaped by multiple interests. We as a nonprofit can act outside of those multiple interests. And I like to use this New York City example to highlight those interests. In 2007, you can see this map. The blue area represents the FEMA minor flood map update from the original map that was from 1983. So in 2007, this was an update for the area of Canarsie. This sits on Jamaica Bay, this area. It's very close to JFK for context. In 2012, Superstorm Sandy hit, and this is what the inundation area of that same neighborhood in Canarsie looked like. In 2015, FEMA proposed a new floodplain map, which I think looked a lot better for the 100-year storm, but New York City rejected it. So in 2016, FEMA said, okay, we're going to accept your appeal, and this is the new floodplain map. So again, First Street as a nonprofit, we don't have to be influenced by these interests. We can depend solely on the data and the science to produce our hazard layers. And so another thing that makes our data different is that FEMA only looks at historical events, and we look at the future. So we include sea level rise, air surface temperature, sea surface temperature, and we use the CMIP5 RCP 4.5 curve in our models in order to get climate projections up to 2050 and have those reflect how flooding will change over time up to 2050. And we like to emphasize that we're here to complement FEMA's approach. We want to provide a way to help bridge that knowledge gap. We're not here to be adversarial. We're really here to help bridge that knowledge gap. So if you look at the map on the right, this shows where the First Street Foundation data finds a substantial number of properties at more risk compared to FEMA. So not surprisingly, if you look in the Midwest and Western areas, those are the same places that had nothing mapped. There's a big departure in terms of number of properties. But interestingly, if you start to look at Appalachia, and then we let our eyes transition over to New York State over here, you can really see that inland flooding, and even New York City, we start to understand that perhaps there are many more properties at risk than what we would expect if we were only to rely on the FEMA floodplain. So how do we do this? Well, our flood hazard model is a combined model. We use tidal flooding, pluvial, fluvial, and surge. We model those 4 different flood hazard types, and we combine them into one layer. And then essentially we produce statistics at every single one of these 142 million parcels. And how do we do that? Well, we have the parcel data. We overlay building footprints when available. So we use the publicly released Microsoft developed building footprint data set. If the building footprint is available, we take the centroid of that building footprint and calculate the statistic at the centroid. When there's no building footprint overlaying a parcel, we calculate the statistic at the centroid of the parcel. We overlay our multiple hazard layers over that building footprint and parcel data, and we calculate the maximum depth at that exact location for each one of the hazard layers. And I should let you know that when I say hazard layers, there are a number of different permutations to those hazard layers. So in terms of return periods, we go from the 2-year, which you can think of a king tide event or a frequent flood event. We go to the 5-year, the 10, 20, 50, 100, 250, up to the 500-year event, which you can think of as a severe hurricane storm. So those are all the return periods we offer in our statistical data sets. And then we offer every single one of those return periods, starting from 2020 in 5-year intervals up to 2050. And then at each one of those years, we offer a low, medium, and high climate scenario. So what I generally tell people is, if you're looking to compare apples to apples to FEMA's special flood hazard area, you would pick the 2020 100-year medium climate scenario. Sorry, that's a duplicate slide. One other thing that is really important to know and perhaps could aid in all of your research is an important part of our flood modeling process that I'm particularly proud of because my team and I did the research. We developed the nation's first flood adaptation database. Currently, it is comprised of over 23,000 individual adaptation projects. Those projects are often comprised of multiple infrastructure features. We have researched 40 different adaptation types, ranging from levees to seawalls to pumps. We've included both green and gray infrastructure projects, and these are all incorporated as a post-processing aspect of our hazard layers. And you can see, if you look at the New York side of things, we found that 60,000 properties are currently being served by protection measures. The most frequent infrastructure type in New York State are levees, next door channels, earthen berms, rain gardens, interestingly enough, and then beach nourishment projects. Down here is an example of an earthen berm project along Long Beach in New York State. So we can talk about this at great length at another time, but something to know that's available as well to you all. I think it would be important if that I go over this. I won't go in depth, but I do like to let people know that, First Street wouldn't be here and we wouldn't be able to produce our hazard layers if it wasn't for all of the open data sets that the federal government puts out. We use NOAA Atlas 14 for our precipitation frequency data. We use USGS stream gauge data, all the tidal data. Without the available data from the federal side, we simply would not be able to do what we do. And I think it's important to recognize that these data sets have been so integral and so important to our modeling process. And beyond those relying on publicly available data sets, we recognize that in order for researchers and government agencies to be able to trust and understand our statistics, not only do we need to make those data sets available, but we actually need to make the methodology behind those data sets available. Our methodology is completely open and transparent. It's also peer-reviewed, and it's important to us that it's not a black box, that people can understand it and help us improve it as we move along and as we mature as an organization. So I very much encourage you to go to firststreet.org to look up our technical methodology, our national report, go to flood factor, and read up on these things. As a little taste for what you can find in the national report, which just came out in June of 2020, when all of these statistics for the 142 million property came out. These are some of the things you can find in that report. So maybe relevant to this group are things like, where are the greatest number of properties at risk in 2020? How do those number of properties increase over time for those municipalities? So if we were to look at Rochester, we see that currently 6,900 properties are at risk today. In 2050, 7,150 properties are at risk. But then there's another table that we've created that shows the greatest relative growing risk. So we can see that Merrick, Long Island currently has 23% of its properties at risk, but in 2050, 63% of its properties are at risk. So these are some quick highlights that could be helpful for you all. They could also be good talking points, to help explain where the greatest risk is. I think it's interesting and maybe not surprising to look at this table and to see that almost all the places with the greatest relative growing risk are in Long Island. We also show flood factors distribution of properties at risk, and we'll talk about that in a second when I go over flood factor. All right, so what time is it? It's 1:15. Okay, I'm going to make this as quick as possible because I do want to talk about the data distribution. Flood factor. So flood factor is our main communication tool. It's the first open source peer-reviewed climate adjusted solution really available. It's produced at the 3-meter resolution. And we do this because if we think that in order to be able to produce accurate property level statistics, we had to look at it in the highest resolution possible. And we actually are endorsed by the National Association of Realtors. They think it's a helpful buying tool and tool in the home buying and selling process. We are featured on redfin.com and realtor.com. And, this has been an interesting experiment for us. And let's get into the tool now. Okay. So this is floodfactor.com. This is the landing page. You can enter city, zip code, address, or state. And the reason why I want to show this to you is because when and if you get our data set, I think actually this is a really good place to go to start to get a bird's eye view of what that data set looks like. So also to note up here are resources that tell you about the tool, our methodology, describe environmental changes, describe our historic flood, which I think will be very, very interesting to what was being talked about earlier in terms of simulations. Remind me to talk about the historic modeling that we've done, and a page that I helped create, which is the solutions page. Alrighty, so let's say we were to type in a place like Baldwin Harbor, New York. I already have it pulled up here. We're going to go into an inland area and a coastal area, just so everyone knows. But for now, I chose Baldwin Harbor, New York, which is in Nassau County, Long Island. We have found that Baldwin Harbor is of increasing risk, and currently 88% of its properties are at risk. The first statistic that we show is how this trend is showing rising over time. This year, we calculate that the total annual flood damages to buildings in Baldwin Harbor would be $237,000, and it's going to increase by 226%. And I can send you all documentation on how we've calculated these things, but if you hover over some of these info buttons, you'll learn a lot more as well. What I think is really helpful is this score map that is not showing up. We'll look at it on the next page because it is on the next page. Sorry, I don't know why it's not here right now. Oh, there it is. It's just taking a while to load because my internet is being fussy. Okay. So what we see here are the flood factors, which are available at the individual property level. So we've calculated a cumulative risk score, and 1 is the least amount of risk, 10 is the greatest amount of risk. So, you know, when I heard earlier people say, you know, that where can we find places that we should encourage development? Well, this could be one place. Where should we find places that we should limit development? I wish this map was actually working, but as you can see, you can start to click on and off and find the most extreme places, the most severe places. When the map is working, it looks a lot better. There we go. So if we were to turn on all these, we would start to see that this whole part has a major flood factor score of 5 to 6. That could be a place that we don't want to be encouraging development. Moving on, this is something that I think could be super interesting for you all as researchers, because we do provide this in our data sets, are the inundation hazard layers. We've recreated about 100 historical storms across the US from 2005 to 2019. We originally did this as a way to like kind of QA/QC our modeling process. And then we realized actually, like, why not just release this data as a way to like encourage understanding of prior risk at the property level. Of course, nothing is working. Let me reload and see if this is going to work. I had it all queued up for everyone. There it is. Okay. And so this also could be helpful to see these inundation layers and to use them for the analysis. Here's the Hurricane Sandy storm surge. We show that 2,000 properties in Baldwin Harbor were impacted. We show Hurricane Irene storm surge event, 278 properties were impacted. And we show the nor'easter of November 2009, where 76 properties were impacted. And again, we have documentation and peer-reviewed articles on how we remodel these historic events. Further on, this is where we start to tell the user about their actual risk. And these are the statistics I was mentioning earlier. We can look at the 0.2% flood likelihood, or in our terms, the 500-year event. We can look at the 100-year event, or 1% flooding likelihood. And we can start to see the number of properties being impacted at each one of those flooding likelihoods. We can also then go up here and see how in 15 years, look how much that number changes. This year, 759 properties are impacted at the 100-year event. In 15 years, it goes up to 1,500 properties. And in 30 years, devastatingly, we find out that 2,300 properties would be impacted by the 100-year event. according to our statistics. So I believe this to be a really powerful tool, especially when you get the property level data statistics that can run analysis that way. We tell our users about, changing environments, click through that. And then we also like to leave people with solutions. So you can learn about green, gray, and more community-oriented solutions. You can click through those and find out a lot more. Okay. Running out of time, but quickly, I wanted to show an example in Binghamton at the property level. This property I found in Binghamton has a flood factor of 4 out of 10. So we consider that to be a moderate flood factor. And I think something that's interesting to show here are some of these info buttons. I encourage you to watch them. They could be helpful to understand more about our methodologies. You click on them, particularly this one where we show the annual flood damage that is expected in dollar amounts to this building structures over time, this specific building. And we used data from House Canary using the automated valuation model provided by them to figure this out. And so, if we change the likelihood of 6 inches of floodwater to this building in 10 years, we can see how the dollar amount changes. If we go to 25 years, we see how this dollar amount changes. If you click on the adjusted building details, and I say, actually, this building is, the first floor is at 7 feet, hit save. It's telling this is just for viewing purposes. Okay, that number goes from 8,000 down to 4,000 because that we changed the first floor elevation to 7 feet. So this can be an interesting tool for people to start to understand how that property risk accumulates over time in dollar amounts and how it can be mitigated through something like a first floor elevation. Similar thing with understanding the contents of your building. And of course, today this is not working, but this is where you can understand your flood likelihoods as well. Alrighty, back to the presentation. Almost done. I think this is the most relevant part to you all, is the publicly available data, and something that I'd love for you all to follow up with me on. Right now, we have taken all of these statistics and we've aggregated them into 3 geographies: congressional district, county, and zip code. And we've taken those geographies and we've put them up on the registry of open data on AWS. So anyone can go and download these data sets and use them for non-commercial purposes. These are some maps to show you what the distribution of one of the data sets looks like. And some interesting statistics to this group could be things like the first street number of properties at risk in 2020 versus the first street number of properties at risk in 2050. And we also provide those at the 5-year return period, the 100-year return period, and the 500-year return period. So I think the real value comes in this 2050 number and be able to start to understand what that looks like in the future. So this is a slide that shows you how you can access that data. I'll be sure to share my presentation with Rachel so you can follow these instructions. And then lastly, we are embarking on this public sector data access pilot program. We really feel that the First Street data should be used for public good, and that we recognize that sharing it with local governments and the federal government as well will allow it to be leveraged immediately for people to use in service to their communities. So if you are a government agency or know any government agencies that should be part of our program, please ask them to fill out this very quick application, and we'll be in touch as soon as possible. We're giving our data out either through our API or through a bulk data download, and we're very excited to talk to anyone that's interested. Thank you all so much, and I really look forward to working with you in the future and hearing so much more about your projects, as they sound really relevant and amazing and impactful.